Hello there and welcome to this channel. My name is Dick van Oeveren, and in this new series of videos, which is actually a follow-up of the video series I just made a couple of months ago about Aruba data center networking with Fabric Composer and the Aruba 10K and the Pensando Services Manager. Um, so this is a follow-up series of videos covering some new stuff that we've introduced in Aruba Fabric Composer 6.4, as well as some videos that show you some additional features like what happens if I make a configuration change on the switch. So what's the behavior there? I would also like to show you some visibility, flow visibility that we can achieve with the Pensando Services Manager. And actually, we can export full flow data. And I'm going to show you that in the video as well. And I would also like to show you the APIs, especially the PSM APIs are very useful, and you can use the APIs to integrate with XDR systems or external systems, and you can do a lot of automation with that. But in this video, it's going to be microsegmentation. With the release of 6.3, well, actually 6.2, but 6.3 is actually the major version that introduced the microsegmentation functionality with Aruba Fabric Composer. We have actually made some improvements in 6.4. We've added some features to the microsegmentation function, and that's something that I would like to show you in this video. If you haven't seen the 6.3 microsegmentation demo, there is this video series again that I've created. It's if I remember from the top of my head, it's video 8, microsegmentation. And that's gonna go guide you through that workflow. Now, before I dive into the configuration, let me just revisit microsegmentation, what it actually does, and why would you use microsegmentation in data center networking. So let me just show you that. Okay, so here we have the situation. We have two VMs. You can see that here. They are both sitting on VLAN 10, and they are attached to a port group. Typically, what happens is that within a switch, these VMs, they can talk to each other. So 10.1.1.2 can talk to 10.1.1.3. Now imagine that a hacker gains access to VM1, 10.1.1.2. It will be easy for him, well, much easier for him to start an attack the VMs that are sitting on the same VLAN, that are sitting on the same port group. So basically lateral attacks are very easy to do, and that's actually something that you would like to prevent. If one of the hosts, if one of the VMs is infected, you want to prevent spreading that infection laterally onto the other VMs. And that is what microsegmentation does. So if we look at, if we look at that situation here, you have this port group and the VMs are connected to that port group and communication is possible. Okay, how can we achieve that isolation? Really what we can do is, and that's something that we can achieve in vSphere, also in Hyper-V actually, but vSphere has this function called Private VLANs. It's actually a very old technology that's being used. Private VLANs are there already for a very long time. And we can use that functionality to isolate the VMs from each other. The concept of a private VLAN is that you use an isolated VLAN, and the VMs are actually connected to that isolated VLAN. With that isolated VLAN deployment, the VMs cannot communicate with each other anymore. And then you have the concept of a primary VLAN or sometimes it's also called a promiscuous VLAN. Now, what we have with private VLANs is that you basically attach the isolated VLAN to the primary VLAN. So all the communication that comes from the isolated VLAN is transferred to the primary VLAN. And then what happens is that really that traffic is being sent out onto the primary VLAN, onto the switch, onto the 10K switch in this scenario. And then what happens is what we can do on the 10K switch, we can redirect that primary VLAN, that VLAN 20. So we also configure private VLANs on the switch, on the physical switch. And what we can do then is we can redirect the isolated VLAN traffic through the primary VLAN onto the DSM, onto the ELBA chip for traffic inspection. And that's really how we can achieve microsegmentation, right? So if we configure this network on the DSM, that traffic is redirected for stateful inspection. So it's really easy to create that microsegmentation. Now, in order to achieve this, actually you kind of like need to configure a couple of things, right? So on vSphere, you have to make sure that you configure a distributed virtual switch with a private VLAN configuration on it. So you configure the isolated and primary VLANs. You obviously have to attach the VMs to the isolated VLAN. So that's the vSphere side. On the switch side, you have to configure the VLANs, you have to configure the private VLAN functionality. Maybe you want to do some routing, so that means that you need to configure some IP addresses on the VLANs. So you need to create SVIs. And obviously, if you want to protect the traffic, you also have to create a policy. These are things that you can do manually with Aruba Fabric Composer, but we can also do this in a workflow. Basically, everything we can do everything in a workflow, and that includes the configuration of the distributed virtual switch, the configuration of the port groups, the isolated primary VLANs, the private VLANs on the switch, the policy on the switch, IP addresses, like everything. And that's what I'm going to show you in the next part of this video. Okay, let's check out Aruba Fabric Composer. We're on the dashboard here. Let's check out the visualization. So what we have here is we have the two spine switches and the leaf switches here at the bottom. And so what we're going to do is we're going to implement microsegmentation here on the 10K1. And so actually what I'm going to do here is, let me just go to the host visualization. You can see the 59.22 here. That's actually the host where we will be deploying microsegmentation on this VMNIC2. You'll see that when I go through the workflow. So remember 59.22 with VMNIC2. That's where the microsegmentation is going to be deployed, and that's the interface onto where the VMNIC2 is connected, 112 of the 10K1. You can also see two VMs here. Let me just expand that one. The 203.104 and the 203.108. These are actually the two VMs that I will be using for the microsegmentation demo. Okay, other than that, let's see, the interface 112 is configured, a link is up. You can see that there are no VLANs assigned. What you'll see later on is once microsegmentation is deployed, you can see that VLAN 1203 and 2203 are assigned. It's actually done through that workflow. So that's not a manual task that you have to do later on. The other thing, private VLANs, there are no private VLANs yet. That's also achieved through that workflow. And for routing, there is no IP interface for that VLAN 1203. Let me just show that to you. So no IP, that's also done through the workflow. And you can also see that there's no VLAN 1203 configured that's for the redirection to the Pensando chip. Okay, and that's also gonna that's all gonna be configured in that workflow. The other thing that's gonna be configured in that workflow is the policy. You can see no policies here. That's also gonna be added. And so let's just dive straight into that microsegmentation here. If we are in the microsegmentation section, you can already see the DVSs that are configured on the vSphere hosts and the port groups that are assigned. And let me just start by creating the, opening that workflow for creating that microsegmentation. Primary VLAN would be 1203, but we'll just give it a name, and the isolated VLAN would be 2203. The host is, remember, 59.22, and I have VMNIC2 here. If you have other hosts that also require that private VLAN configuration, you can just add them, right? So it's pretty straightforward and simple. Okay. If we go to next, we give the prefix for the port group name. The primary VLAN is 1203 and the isolated VLAN is 2203. And now what we can do, which is different than in 6.3, what we can do for the isolated VLAN VNICs is we can actually add the VMs to that port group from AFC. So it's not a, afterwards typically you would have to manually in vSphere move the VMs to the right port group, but we can do that here in AFC straight away. And what we're looking for is the 203.108 here and the 203.104. Okay, and what we'll do is we add those to the list of isolated VLAN, VMs basically. So the next two sections in the workflow are used for if you want to create a link aggregation group on the vSphere host. So this part of the workflow allows you to configure that. So instead of configuring it on vSphere, we can also do that in Aruba Fabric Composer now. At this stage, I'll just have a single interface connected, but you can do that. So I'll just skip this one because it's a single interface again. Okay. For the VRF that I will be configuring, it's the GVA VRF, and I need to create this network 1203 and this IP interface, this SVI for VLAN 1203. So let me just add that, VLAN 1203. And you can already see that it's pre-filled in. This is very similar to what we already had in Aruba Fabric Composer 6.3. So that's your VLANs being created, and also create the SVI. I only need to create it on the 10K one because that's where my microsegmentation is. My IP address would be 203.0/24, and my gateway IP address would be 10.6.203.1. I'm not using any active gateways or VSXs, so we can just leave it like this. I'll just give it a name, VLAN 1203. Next and apply. Okay. And then next is creating the policy. There's no policies as shown earlier. Let me just add a policy saying block SSH. Right. We'll do that same policy that we did before. Block SSH. So let's add some rules. Let's add a new rule saying block SSH because I want to block SSH. I want to drop it. And same as with 6.3, I can select endpoint groups. Let me just add an endpoint group, say subnet 203. And the endpoint groups, they can be VM names, VM tag, for example, or VM name. Or we can just add a manual endpoint entry, which would be 10.6.203.0/24. So any VM with an IP address in this range will belong to that endpoint group. I can do subnet here as well, subnet 203 for the destination end group. And the application would be SSH. There are a lot of SSH, there are already a lot of predefined applications in here, and SSH is actually one of them. Next, apply. So that rule is being added, and I want to add another rule, and that's actually, I can also add existing rules, which are basically permit any, for example. So if you already have rules configured, I can just add them. Right, apply. So what will happen here is I will be blocking SSH and will be permitting any other traffic. I want to enforce it on the this fabric, on egress, and on the GVA VRF, and on the network 1203. And actually, that is already pre-filled in, so I don't have to I don't have to define it here. I can remove it here and just add it again, but the workflow already pre-filled this in based on the information that it had before. Right, so I'll just remove that one and then go next. We have the summary here, apply it, and we have that policy defined. And that's really it. So that's going through that workflow. Once I hit the apply button, it will do all the cool stuff for you. Before I hit the apply button, I just also quickly want to show you the vSphere environment. Here's my vSphere environment. This is the Amsterdam cluster. You can see the D switch to Aruba. Let me just expand that one. And you can see the dummy group here, and you can see those two VMs sitting in here. So what happens when I hit the apply button, there's a new DVS being created. The VMs are being moved onto that isolated port group. The private VLANs are configured on the switches. The policy is configured, etc. Before actually hitting that apply button, let me also show you PSM. You can see that the VLAN is already, the network is actually already created and the policy is already applied, but the private VLAN is not being is not configured yet, right? So so that means that there's no redirection yet. Okay, let me just hit the apply button here and see what happens. Okay, so you don't see the private VLAN information in here yet, so you don't see the DVS, so it could take like a couple of seconds. Let me just refresh the screen, and now you can see that DVS in here, where VLAN 1203 is the promiscuous VLAN and 2203 is the isolated VLAN. Let's move back to vSphere. Let's see whether the DVS is created. You can see it here now. It's being created, and you can actually see that the two VMs are in here. Okay, let's move back to Fabric Composer, go into the visualization, and you can now also see that 112 here is connected. You can see that VLAN 1203 and 2203 are applied, and you can see the VMNIC here being connected to that 112, and then going all the way to the right, you can see the two VMs here, the 104 and the 108. So you already saw the policy in there, the block SSH policy, and also the private VLAN. You can see that private VLAN information in here as well. So that's all done through a single workflow. Now let's put it to the test. Now here we are on vSphere. Let me just go to the 203.104, open a terminal. And so ping should be working. Let me just ping the gateway first. And I should also be able to ping the 108 from the 203.104. And that's also working fine. And now let me SSH, try to SSH. So according to the policy configuration, I'm blocking SSH. So I should not be allowed to get onto the 108. And you can see that it is blocked. So the policy is actually enforced. And I can test that. So actually I'm in PSM here. You can see that the policy in here is in here and it's assigned to 1203. Let me just remove that in PSM. I can actually also do that in Fabric Composer, but I'm in PSM now, so I can also do that here. So let me see if the SSH is working now. And you can see that I'm getting it. Oh, probably a wrong password now. There you go. And I'm on the 108. So you can see that actually that policy is enforced. And that's microsegmentation. And that's all for now. Next video is about making changes to the switch and see what the behavior is in Aruba Fabric Composer. So as a teaser, shouldn't worry too much if you make changes to switches because they will be enforced on the switches. But you know, next video you will see all of that. Thank you for watching, and if you liked the video, just do the thumbs up. If you have any suggestions or questions, let us know, and we hope to see you soon on this channel. Okay, bye bye.